Good afternoon.
Afternoon.
Yeah, my name is Azeez Jelili, and I'm here to present an experimental work which based on the fabrication of natural dye-sensitized solar cells using berry and watermelon as dye. Next slide, please. Introduction: dye-sensitized solar cells. Dye-sensitized solar cells, also usually referred to as dye-sensitized cells, belong to the third generation photovoltaic solar cells, which transform any visible light into electrical energy. This recent class of advancement in solar cells can be similarly linked to engineered photosynthesis due to the manner in which it tries, duplicates tiny nature absorption of light energy. Dye-sensitized solar cells are proposed in the year 1991 by Professor Michael Grazel and Dr. Brian O'Regan at Ecole Polytechnic, and in their work, they use ruthenium manufactured dye as their sensitizers. And after that, they were able to record a high success of about 12% efficiency in their cells. And since then, the use of dye-sensitized solar cells has been invoked. In recent time, we found that the ruthenium are rare metallic oxides, which are toxic and expensive, and they are not really available. In lieu of this, research trend is now moving to the use of what we call natural dye-sensitized solar cells, in which dye extracts were being extracted from a natural plant, which can be leaf, roots, stems, or any part of the plant as a dye, in order to replace the toxic and expensive ruthenium oxide. As we know, in Nigeria, there are a lot of electricity problem generation in the country, people based on fossil fuel. So the idea is just that we need to look for an alternative way of generating our solar energy, which is economically friendly, which will also be not expensive, and which is going to give us a high efficiency of energy. Next slide, please. The aim of this work is to fabricate natural dye-sensitized solar cells using berry and watermelon as dyes, and our objectives are to extract dye from berry and watermelon using the extraction dye, to measure the open circuit voltage and current and to use this to calculate and determine current density, maximum voltage, power point, the same thing with current, the fill factor, and efficiency, and to make recommendation. Next slide, please. These are a review of some of the work. This review was done by Shamai in 2018. It shows some of the available of dye from natural plants. You can talk of the anthocyanin, the carotenoid, the chlorophyll, and flavonoid. So these are the references of some of this work. Next slide, please. In our work, we are able to fabricated a dye-sensitized solar cell using titanium oxide, and the figure 2 above here shows the dye that we are able to fabricate it, and the other picture there shows how we are able to measure the major component, major parameter from our fabricated dye, which has the open circuit voltage and the short circuit current. Let's go to the next slide. So we use the open circuit voltage and the current density, the short circuit current, to plot this graph. What we did was that after we have obtained our open circuit voltage, we are able to get the current density by dividing the surface area of our deposition with the values of the open circuit current that we get. So we then plotted the graph of current density against voltage. And on this graph, we can see the first graph is labeled B. That's the curve for our solar cell with a berry, and the other one is for the curve with watermelon. And from the graph, we're able to get maximum power points for voltage and maximum power point for current density. Next slide, please. From the graph, this is our result for Berry. The first table, the column, it shows the value for our short circuit current. The second one shows the value for our open circuit voltage. The third column is for the current density. And we all know from the simple mathematics that power can give us, from the voltage and current, we can get our power. And that's how we're able to get this power. We calculate the average of each of the value. We're able to get this to get the value. And from the formula, this formula is from Gong et al. In 2015. We're able to get the fifth factor. Fifth factor is one of the factors that we use to characterize a cell, and we're able to get our efficiency. For the Berry, this is the efficiency we get 0.009%. Please, next slide. And for watermelon, we get efficiency of 0.0002%. These values are very low, maybe because of the fact that our cell was grown on a normal glass. We did not use conducting glass for our experiment. The reason for this is just that we want to see if at all there's going to be a conduction or whether there won't be any conduction. Work is ongoing with the use of our FTO, that's we call a conducting glass, and we're going to compare our results. Next slide, please. In conclusion, the efficiency of these cells are below prohibitive efficiency, and this could be as a result of using ordinary glass because there were no availability of FTO. The further research is ongoing with the use of FTO, and comparative analysis will be carried out. Thank you for listening. Next slide. This is our reference, and that's all.